The building was also surrounded by smaller astronomical equipment, libraries, offices and accommodation. The observatory even had its own dedicated mosque. I suppose it is a little disappointing that there's not that much left of the place now. So you really have to imagine what it must have been like back in its heyday. After all, what Al-Tusi built here was nothing less than the world's greatest observatory for 300 years. And like any modern-day international research institute, he brought together the world's greatest astronomers from as far away as Morocco and even China. I mean, it must have been a really great, buzzing atmosphere to work here. With his new observatory and world-class team, Al-Tusi was now ready to fulfill Ibn al-Haytham's dream, to try to make Ptolemy's model scientifically rigorous. First, they attacked the mathematics. As well as the Tusi couple, they invented other systems of planetary movement. And with these new systems, they were able to calculate mathematically consistent models for many of the celestial bodies. Mercury, Venus, Mars, Jupiter, Saturn, and the Sun and Moon. Al-Tusi and the astronomers he brought together created what became known as the Maragha Revolution, which was a complete paradigm shift in astronomy, overthrowing the old Ptolemaic view.
What Islamic scholars and astronomers like Al-Tusi do is to organize and make sense of mathematical astronomy at a level of unprecedented accuracy, using instruments more precise than had been built before, over longer timescales, with predictions of the positions of planets and stars that no one had previously reached. That at Maragha or at Alamut, we see, I think, genuine revolutions in the level, scale and intensity of mathematical astronomy.
But there was still a problem. The new models were mathematically coherent and they dispensed with Ptolemy's unwieldy equant. But they still firmly placed the Earth at the centre of the universe, and that inevitably meant that their descriptions of the heavens were intricate and complicated, with epicycles, deferents and couples. It was like some great cosmic gearbox. It would require a huge leap of imagination to make the next step in our story. And that next step would take place 2,000 miles from where I am now. In my view, the last phase of the Maragha Revolution took place not in Iran or anywhere in the Islamic Empire, but here in northern Italy. Based on the work of Muslim scholars, places like the University of Padua were already starting a new scientific movement, the Renaissance. Back in Padua, where I began my journey, I now understand why Islamic astronomers were so important to Copernicus. They gave him his motivation. He's the first European to share Ibn al-Haytham's deep aversion to Ptolemy's cosmology. And that's what makes Copernicus not the first great astronomer of a new European tradition, but the last of the Islamic tradition.
Okay. This is the second edition.
As we've seen, many of the complex mathematical models Copernicus uses in his new heliocentric model, like the Tusi couple, are copied from Islamic astronomers. But more importantly, it's Copernicus's deep desire to bring mathematical consistency to cosmology that he really owes to his Islamic predecessors. Copernicus's ideas set in motion a train of scientific revelations that would eventually lead to Isaac Newton and the discovery of gravity. In Newton's hands, Ibn al-Haytham's dream of an astronomy with rigorous and coherent mathematics, which agrees with experimental observation, finally took place. But this begs two crucial questions. Why was the great astronomical project which Islamic astronomers began completed in Europe and not in the Middle East? And how did knowledge of Islamic science get to Europe in the first place? The answers to these questions lie in one of the most beautiful cities on earth, the Queen of the Adriatic, Venice. Venice was founded on a swamp off the coast of Italy and felt itself separate from Europe and not bound by its laws and traditions. And as Shakespeare famously pointed out, the two most important aspects of Venice were its merchants and its long-standing links with the Arabs or Moors. It was a rich and complicated relationship, sometimes based on piracy and theft.
The story goes that in 828, two Venetian merchants stole the bones of a famous Christian saint from Venice's rival city across the water, Alexandria. The bones belonged to St. Mark the Evangelist, and they brought them back here to St. Mark's Square.
But without doubt, trade with the East brought to Venice great wealth and an exchange of ideas, customs and people, as Venice expert Vera Costantini showed me.
So this is called Campo dei Mori because, as you can see, at the corners there are statues of were called Moors.
Yeah. Oh, there's another.
Yeah, there's another one with a turban. The beard was recommended to Venetian merchants even when they went to the East. There were manuals written for Venetian merchants.
How to blend in.
How to, yes, how to be respected in the East.
Yeah.
Oh.
As Venetians traded more and more with their Muslim neighbours, the influence of Islam was more strongly felt. Arabic coffee culture became hugely popular, as did Islamic styles of architecture with their characteristic arches and decorations.
So the next thing I want to show you is the Palace of the Camel. When Venetians traded in the East, the unity of measurement of a load that could be loaded on a dromedary was called a carico. And it was the exactly same unity of measurement they had in the East, and it was called yoke.
So it's not coincidence that they...
No, it's not,
that they actually imported that unit of weight.
Yes, of measurement, yeah, of weight.
And with the Arabic trade came the Arabic books. The great 9th century Arabic text on algebra appeared in Latin in the 12th century. The same century saw the arrival of Arabic astronomical tables. And in the 15th century, the famous Canon of Medicine was first published in the West. And this influx of learning